In this lesson, we will be learning how to use the unit ppm. ppm stands for parts per million, and if you had 1 ppm, that means you have 1 gram of solute for every million grams of total solution. In order for us to prevent getting too many zeros, so 1 divided by a million is 0.12345 grams over grams, right? To get rid of all these zeros, we're going to go ahead and multiply it by 10 to the 6. So then 1 divided by a million times a million is 1. Okay, so ppm is used at very low concentrations where you have only a little bit of solute and a lot of solution. So the formula goes like this. It's part over whole. This is solute over solution. In mass percent, we multiply by 100, but in ppm, we multiply by a million. The other unit for ppm is microgram per milliliter. Again, solute over solution. Okay, and I will prove to you why microgram per milliliter is the same as 1 ppm. Let me do that now. I'll do it right here. We're going to prove that 1 ppm is the same as 1 microgram per milliliter. So let's try 1 microgram per milliliter, 1 milliliter. I'm going to convert micrograms to grams. So micrograms to grams. Gram is bigger. King Henry died by drinking chocolate milk Monday night playing football. So 1, 2, 3, 4, 5, 6. So 10 to the 6. So I just converted the grams to micrograms to grams. Then I'm going to convert milliliters to grams. So we have, use a different color. So this is milliliters. I'm going to put it on the top to cancel it. And I'm going to go to grams. Because this is in water and the density of water is 1 milliliter of water weighs 1 gram, even though there's a little bit of solute present, it's still the same density because the solute is very small. So I take out the milliliters, and now I have grams over grams. And if you multiply the top, 1 times 1 times 1 is 1 grams of solute over 1 times a million times 1 is a million grams of solution. So what I did is I proved to you that 1 microgram per milliliter is the same as 1 ppm. Okay, so you will have 2 equations that you can use, and depending on the problem, you can use one or the other. Okay, for example, it says find the ppm of solution of 0.005 grams of sugar added to 1 liter of water. So you can either use the top or the bottom. I think I'm going to use the top equation right here because this is in grams and this is in grams, so I don't have to convert that. And then the liters, it's easy enough for me to convert that to this grams. So I'm going to write the equation. That's my strategy. ppm is equal to grams over grams, solute over solution. Okay. So this goes on, the 0.005 goes on the top. The 1 liter needs to be converted to grams. So let's see, 1.00 liters. 1 liter is 1,000 milliliters. 1 milliliter is 1 gram. So that is equal to 1,000 grams. 1,000 grams. But I have to add the solute. This is the solvent, and the solute. So I have to add the 0.005. Okay, which in this case, in ppm molar concentrations, the 0.005 is way past the significant figure, so it's not really going to matter. This will be 1,000.005, so the number is not going to change. Even if you don't add the 0.005, it's not going to matter. So times a million is equal to, I think that is 5 ppm. Okay, the next one is this problem. It says find the ppm for 5 micrograms in 1,000 grams. So I look at my formula here, and I think I will use the second equation now because I have it in micrograms, and this is already in micrograms, so it's really simple. So the formula, write the formula first, micrograms per milliliter. Okay, so that's the formula. Then plug in your numbers. This number will go on top, and then this is in grams, so I just need to change that to milliliters. 1 gram is 1 milliliter, so that's the same as 1,000 milliliters. So 5 divided by 1,000 is equal to 0.005 parts per million. Okay, so to summarize, you have two equations for parts per million. And what does it mean? It means if you have 1 ppm, you have 1 in a million. So very low concentrations. This is grams over grams. And if you have 10 ppm, you have 10 in a million. 10 grams in a million grams of solution. Okay, and that is ppm. Let's go ahead and do the next formula here. This is the molality formula. So this is a little bit strange. Molality versus molarity. Two different formulas here. First, molarity, you learned from the previous video, has an R, while molality has an L. Okay, and the symbol for molarity is uppercase M, while this is lowercase m. Okay, molarity is moles of solute over liters of solution. Okay, while molality, so the top is the same, so these two are the same. The bottom is kilograms of the solvent only. So this one's really easy to do because all you have to do is weigh the water and you can plug it in there. Okay, so that's the formula, and it's very simple to use it. You just, it says what's the molality, so I will write the equation first. Moles over kilograms of water. Okay, moles of solute. Okay, so in this case, you have 5 grams of HCl, and I will change that to moles. So 5.00 grams of HCl. 1 mole of HCl is, I believe it's 36.46 grams. It's equal to 0.137 moles. That will go here. And then kilograms of water, just change this to kilograms. 250 grams, 1,000 grams in 1 kilo equals 0.250 kilograms. Put that here, and you have your answer, which is 25.6. I'm sorry, no, that's not molality. Oh no, molality is 0.548, yes. Molal. Okay, very simple. All right, this one is very simple as well. Let's go ahead and write the formula. Molality is equal to moles over kilogram. For this one, they gave us the 1.75 here. Then the kilograms, so the grams of water here, I'm going to change that to kilograms, 0.250, easy. And then here I will find the moles. So multiply that, I'm going to get X is equal to 0.438 moles of NaCl. Change that to grams because they're asking for grams. 1 mole of NaCl is, when you add the molar mass, 58.44 grams is equal to 25.6 grams of NaCl. And that's it. That's how you use the formulas.